Hello, everyone. Hopefully, you're safe and sound in week two. I apologize about this coming out late, but I had many errands that I had to run today. My parents are much older, 71 and 68, so they were not going to the grocery store. So I had to run quite a bit of errands for them, and it took me a lot longer than I thought. But that's all said and done, so ready for week two. To give you a heads up, there's going to be 3 activities this week since we were supposed to meet on Monday, Wednesday, and Friday of this week. Obviously, we're not. But because of that, so I'm going to have 3 activities, one for each day. I know everyone's life right now is probably very chaotic and nothing is predictable. So I'm releasing all of the information at once as opposed to doing one on Monday, one on Wednesday, one on Friday. So there will be 3 videos. This is the first one. This will be on Monday. There'll be another video for Wednesday, another video for Friday. But I'm going to release all those videos on Monday itself. So to start, we're just going to start with very basic stuff with magnets, and we're going to take a look at one of the equations and kind of go from there. So first thing is some quick basic stuff about magnets that you should just be aware of, but in case you're not, kind of middle school review, if you will. We'll start with this. First things first, there's always a north and south pole. You can't have a north pole without a south pole, so this is different than electricity where you could have a positive charge without a negative. In magnetism, it's a little bit different. If you have a north pole, that means the south pole does exist. If you take a bar magnet and you break it in half, that means you get 2 magnets, and each magnet has a north pole and a south pole. The other thing about the direction of the field lines, the field lines leave the north pole and enter the south pole of the magnet. And yes, so the next thing I want to talk about is how wires get involved in this. So magnets are actually created by electrons. And as the electrons are spinning, they create very small magnetic fields. In certain metals, in particular iron, which is ferromagnetic, all of the electrons are spinning the same way. So therefore it will create one very uniform magnetic field from all of the electrons. But the focus today is actually on wires. So if spinning electrons can create magnetic fields, then so can wires, because wires, if they're conducting current, force all electrons to move in the same direction. This equation here shows us what exactly the mathematics looks like. The magnetic field is B, and we measure the field in Teslas, abbreviated with a capital T. To give you some perspective, the Earth's magnetic field is about 45 microteslas, so 1 Tesla is quite a significant amount of magnetism. Mu naught is a fundamental constant. This is the magnetic permittivity. Loosely translated, it explains to you how effectively the magnetic field travels through a medium. For vacuum, mu naught is 4 pi times 10 to the negative 7th. I is the current created in the wire, measured in amps, and R is your distance from the wire. And we measure the distance from the wire in meters. So for example, if I have a wire carrying current, say this way, and I want to know what's the field strength here, this would be my R value. I is however strong the current is, and mu naught is a fundamental constant. 2 pi is also a constant. So in this particular case, you would see if you increase the value of R, that is going to weaken the strength of the magnetic field. The last thing, and probably the trickiest thing, is how does the direction work? And that's where this video, or not video, but image comes in. So the magnetic field lines are forming concentric circles around the wire. And the way that we establish which direction are those circles traveling in is we do what we call the right-hand rule. Imagine grabbing the wire. You can use a pencil or a pen to simulate this, and you grab it with your right hand because it's the right-hand rule. And you point your thumb in the direction of the current. You pay attention to the way that your fingers are wrapping around that wire. The direction your fingers are wrapping around the wire is the direction of the magnetic field. The next thing you'll find for day one is some notes to show you how the mathematics works, and then a web assignment to try some practice on your own. Have fun.